Hi friends, good morning. Welcome back to another session from design of compression members. That is, today we are going to see the new topic, that is column bases. This is our today's content. Now coming to the column bases, column base will transmit load from column to concrete foundation. This column base distributes the load on wider area. Because of distributing this wider area, the intensity of bearing pressure will not exceed the bearing strength on concrete foundation. In general, there are three types of column bases, that is slab base, next gusseted base, and next one is what? Grillage foundation. Now we are more concentrated about this slab base. If I try to draw the figure here, now where you can see first of all this column bases means, if you go and see the railway platforms, where you can see this column bases, where we will be sitting on some round type stage, that next all advertising boards will be placed to one vertical member. There you can see this column bases. And in case of roof trussed function halls, all these places where you can see the column bases. Right. Now if I take consider one I section. Right. It has to be connected, this column, it is to be connected to the base plate, which is also known as a slab base. Under this base plate or slab base, it will be having a concrete foundation or pedestal, we call what, right? This is concrete pedestal. This is what? Concrete pedestal. This is called as what? Slab base or base plate. This is what? Column. Okay, and how they are placed? They will be welding here, here. Now to this base plate, column is attached. Well, how this base plate is attached to this concrete pedestal means by anchor bolts. Why? Anchor bolts. These are nothing but called anchor bolts. Okay. Now if I see the top view of this section, how it will be means, this is I section, this one, this one, this, and here it will be, right? Now it is placed on what? Slab base. Okay, how it is placed? This is welded here, okay, and here, right. Under this slab base you have a concrete pedestal. To this concrete pedestal, base plate is run with bolt. So it may be 2-side or 4-side, it depends upon the loading. Okay, so this is the basic. Now what we are going to do in this one means, we are going to design, till now, till this topic, before what we have done is just we have designed this column. Designed in the sense, for the given load we have chosen the section. Okay, now to this column you are going to design the base. You are going to design the base, right? That is, it has been categorized into two things. One is design of slab base, and next one is what? Design of concrete pedestal. Is it okay? Now we'll see the design procedure, what it involves. And first one is design of slab base. Slab base, which is also known as or base plate, right? This will be concrete, made up of concrete. This will be made up of steel, and this is also made up of steel, right? Now what the steps involved in design of slab base is, first is you are going to decide the size of slab base, means dimensions, length and width. After that, thickness of slab base, thickness of this one. Okay, next we are going to decide later on, after completing this one, next step involves design of concrete pedestal. Now what it involves? Dimensions, means length, width and depth. And last one is what? Connections. Okay, this is the stepwise procedure. Okay, now first we'll discuss what? Size of slab base. Size of slab base. Okay. As usual, first working load will be given. You have to factor it. So factored load is equals to, which is denoted by PU, which is equals to 1.5 into working load. Okay. Next, now while designing the size of slab base, you have to consider the bearing pressure of this concrete. In general, when you are going to design the foundation footings of a RCC footing, you will be taking SBC as a reference to calculate the area, right? Here you are supposed to take the bearing strength. Okay, first calculate the bearing strength of concrete, bearing strength of concrete, which is 0.45 into FCK. What is this FCK? With what grade you are going to construct that? M20 or M25 or M30, like that. So 0.45 into that particular value, you will be getting the bearing strength. Later on, next, area of base plate required is equals to load by 0.45 into FCK. Load by 0.45, right? After that, size of base plate. Okay, it all depends upon two. If you want to go for square base, okay, square base means direct is nothing but area. Area means root of B, right? Root of area will be getting the yes. Next, for rectangular base, L into B will be the area. While doing the problem, it will be understood how to take, right? Now here you got the slab base plate sizes. Next, you have to decide the thickness. For that, I will try to draw one figure. Clearly see here. Suppose this is the I section you got. Okay. To this I section, to this column section, we have decided the what? Base plate. Okay. This is what? H. This is, suppose say it is a rectangular B and L, right? Now these are nothing but projections. This one are nothing but projections. Okay. Now suppose, see here, first I have to calculate the difference. I want this one, L minus H. So L minus H means I will get this two sides by 2. You will get some value. Okay. Next, B minus, this is width of flange. Okay, BF by 2. Okay. Now you give this as a and B. A should be always such that larger projection side, and B it is to be given with a smaller projection. A with a larger projection and B with a smaller projection. In general, always try to keep these projections what as a equal. A and B should be equal, right? Now there is one formula to find out the thickness of base plate, which is equals to TS equals to under root of 2.5 into W into A square minus 0.3 B square into gamma m naught by Fi. This terminology value, okay, should be greater than or equals to thickness of flange of the I section taken. Now here in this gamma m naught 1.1, Fi yield strength of the steel, and A is this one, B is this one. Only thing unknown is what? W. That is W equals to what? Intensity of pressure. Intensity of pressure, right? So intensity of pressure, which can be calculated by the W equals to PU by area provided. Means generally here you will be getting some area, okay, you will be making it round up. This is the required, and you will be finalizing the dimensions that you have to calculate. Area provided. While doing the problem, it will be very easy to understand, okay. So with this we have completed the design of slab base size and thickness. Next we will decide the dimensions of concrete pedestal. Dimensions of a concrete pedestal. Dimensions of concrete pedestal. Okay, so here while designing the dimensions, total load acting on the pedestal will be equals to, okay, P plus self weight of pedestal. You can observe here, this is P, not factored load, working load we are taking, right? Now what is this self weight? Means you can take from 15 to 20% of this load, axial load, right? Next, area of concrete pedestal. Okay, so area of concrete pedestal by is nothing but total load by SBC of soil. What is this SBC? Safe bearing capacity of soil. Okay, safe bearing capacity of a soil. Why again here we are involving soil in steel structures? See here, as per our previous figure, okay, column is resting on steel member, that is a base plate. Base plate is resting on concrete pedestal. This concrete pedestal is lying on a soil. Okay, so for that reason, while designing this base plate, we are taking this as a reference, the bearing capacity, and while designing the concrete pedestal, you are supposed to take the SBC of the soil. Okay, now SBC of the soil, you will be getting what area required, right? Now next, size of concrete pedestal, size of concrete pedestal. Okay, that is what? Root of area. This is AC, root of AC, that is for square. Next, in the dimensions you got area means L and B. Next one is what? D. Next one is what? D, that is depth of concrete pedestal. Depth of concrete pedestal, right? So here you have to assuming dispersion, load dispersion angle as 45 degrees. Okay, therefore depth of pedestal equals to BP minus BS by 2. What is this BP minus BS by 2? This is what? Width of pedestal minus width of slab base by 2. Okay, if I see the plan, this is width of pedestal minus width of slab. This is what? By 2. Okay, means 45 degrees dispersion means you will be getting 1 by 2 of the differences, right? Right. Shall we? Next one is what? Connections. Next one is connections. Okay. Connections is nothing but slab base. It is to be shown with the fillet welds. Okay, and slab base connected, column connected to slab base, it is fillet welds, and slab base connected to concrete pedestal, it is bolts. Okay, now we'll try to solve one problem on this one so that it will be clearly understood. Okay, right. On column basis, so a steel column consisting of 2 ISMC 250 297 Newton per meter placed back to back at a clear distance of 70 mm. It supports a total factory load of 800 kilonewtons. Design a slab base, okay, for the column. The column is supported on a pedestal made of M20 concrete. Take yield stress of steel the first step is what? Design of slab base. Okay, so already load given is a factored load PU. Here it is factored load, it is 800 kilonewtons. Now bearing strength of the concrete is equals to 0.45 into FCK. So 0.45 into 20 which is equals to, how I am taking 20, M20, so 9 Newton per mm square. Next, area of base plate required. What happens? PU by 0.45 into FCK, that is 800 kilonewtons into 10 power 3 newtons divided by 9, this one. Okay, so (88.88 into 10 power 3 mm square). This is the area required. Okay, so size of base plate. Okay, here anything you have mentioned, rectangular or square? No. So size of base plate is nothing but using square, that is B equals to under root of A, 88.88 into 10 power 3, so 298.4. So I will round up to 300 mm. So provide size of base plate as 300 mm by 300 mm, 300 mm by 300 mm. Okay, right. Next, thickness of base plate. Formula, first we'll write formula. TS equals to under root of 2.5 into W into A square minus 0.3 B square into gamma m0 by Fi. This value should be greater than or equals to TF. This is the formula. Okay, so first we'll try to draw the figure. Okay, for drawing the figure, first you have to write the properties of ISMC 250. What is that you are required? Channel sections, right? Yes, ISMC 250. For that, area is 3867 mm square and H is 250 and width of flange is 80 mm. Thickness of flange is, here I am seeing 14.1. Right. Now for that, what we do is we try to draw the figure 80, 250. Next gap is how much? Clear distance of 70 mm. So this is 70, this is 80, this is 80. So 80 plus 80, 160 plus 70. How much it is? 230. Yeah? Yes, 230. 230 means remaining total width of base plate is 300 we are providing, right? So here 250 means 25, 25. Here 230 means 35, 35. So this is 300 by 300. 300 by 300. So first we will see these projections. Okay. So 300 minus of 80, 80, 160 plus 70 means 230 divided by 2. So how much? 300 minus 230 divided by 2. It is 35 mm. Next 300 minus 250 by 2. It is 25 mm. Okay. So this is considered as A larger projection, is considered as B shorter projection. Next, intensity of pressure. Intensity of pressure, that is denoted by W, which is equals to PU by area of base plate provided. Okay, so 800 into 10 power 3 divided by 300 by 300. So 800 into e power 3 divided by, so 8.88 Newton per mm square. Now substitute everything here in this formula. Then TS equals to under root of 2.5 into 8.88 into 35 square minus 0.3 into 25 square into 1.10 divided by 250. So you are getting how much? 10.06. Okay. which is less than thickness of flange. So means 10.6 less than 14.1. So provide thickness of slab base as 14.1 mm minimum. Say we'll go for 15 mm. Therefore size of base plate is equals to 300 by 300 by 15 mm. Okay. So our next step is design of concrete pedestal. So for that, total load acting on concrete pedestal equals to axial load plus self weight. Now here, first of all, axial load equals to what? Factored load by 1.5 means 800 divided by 1.5. So 533.33 kilo newtons. So self weight of concrete pedestal can be taken as 15% of axial load. So 15 divided by 100 into 533.33. So 533.33 into 15 divided by 100. So 79 point, say it is 80 kilonewtons. Now total load on pedestal equals to 533.33 plus 80. Okay, it is 613.33 kilonewtons. Now area of concrete pedestal, okay, is equals to total load by SBC. Here this is the total load. SBC of soil given as 190 kilonewton per meter square. So 3.22. So size of concrete pedestal equals to B equals to under root of 1.79 meters, so I consider as 1.8 meters. Now, assuming dispersing angle for load is 45 degrees. Okay, therefore depth of concrete pedestal is equals to width of pedestal minus width of slab base by 2. That is, what is width of pedestal? You got 1800 mm minus slab base, it is 300 divided by 2, so it is 750 mm. Therefore provide concrete pedestal of size 1800 by 1800 by 750 mm. Okay, also do the connections, and they have not at all mentioned in the question, so we'll stop this question up to here. Next, we'll try to move for one more small topic, that is built up columns. Built up columns. Okay, now here what are these built up columns? Means when more than one rolled steel sections like 2I sections, okay, 2 channel sections, right, or 4 angles, means like this: 1I section, next to one more I section, using as one single unit. Next one channel section, what we done next just now, the problem. Okay, next angle sections. Okay, to this all are used as built up columns. Okay, now in order to act these 4 different angles sections as a single unit, okay, you have to go for some connections. Okay, those connections are nothing but lacings and battenings. Now, what is this lacing? It is a means of connecting different components of built up column. Okay, in order to connect these, we are going to this one. Okay, now what material we will be using in order to go for lacings? Means any flats, angles, okay, channels, and some tubular sections. Okay, can be used, and these are especially used in case of eccentric loadings. Whereas battenings as battenings are nothing but it is used by doing with plates only. Okay, and this is normally used for axially loaded columns. Okay, now here if I see this lacings, we will be having a single lacing and double lacing, single lacing or double lacing. Okay. Now if I try to show here, this is a single lacing pattern. If one more is like this, coming like this, this is nothing but double lacing. Okay, next, whereas this is nothing but a battening. Where you can observe these things, I will place some I will post some figures after this topic. Okay, please see those posts, examples of lacings and battenings, and thank you for watching my video. And in the next class we'll try to learn about the design specifications of lacings and battenings. What important lacings and battenings are there. Okay.